Improved cook stoves, known as ICS, are designed to burn biomass more efficiently, minimizing both wood consumption and household air pollution. They range from artisanal stoves such as the one in this image to more high-tech versions like this one here. An increasingly popular rhetoric amongst academics is that we should focus on making the clean available rather than the available clean, meaning that we ought to move away from promoting wood-burning stoves at all to fuels such as electricity and LPG. But the reality of the challenges of increasing access to clean technologies described in this video means that ICS are likely to remain an important component of clean cooking policies for rural areas in years to come. The first main advantage of improved cook stoves are that there is no need to switch to a different fuel. This means that households can continue to gather biomass for free. For this reason, it is well suited to rural areas. Because households are still cooking with their traditional fuel, it may be perceived as more culturally compatible than transitioning to an alternative fuel. However, because wood is still being combusted, the harmful environmental effects of biomass cooking still prevail. Similarly, the burden of gathering wood fuels continues to be borne by women and children. Nevertheless, both of these impacts are reduced because improved stoves use less wood than traditional ones. Research has shown that for almost all improved stoves, household air pollution emissions continue to exceed the healthy limits defined by the World Health Organization. This means that people cooking on improved stoves are still being exposed to harmful levels of pollutants. Electric cooking devices such as kettles, induction hobs, and electric cookers are gaining traction as a candidate to replace biomass. As access to electricity scales, so does the potential for electric cooking, which is starting to become cost competitive with alternatives even in low-income countries, and especially when low-power devices are used. The main advantages of electric cooking are that it has the potential to be truly clean when the electricity used comes from a renewable source. There are synergies with the wider energy sector, as it also utilizes the electrical infrastructure, which means that it has the potential to be very cheap in the future. Electric cooking is also extremely convenient for the cook, who simply turns the device on and off on demand. On the other hand, electric cooking is very energy intensive, which exacerbates the issue of peak demand and makes it a very expensive option in some places. Transitioning from cooking with biomass to cooking with electricity requires significant behavior change, as the two fuels are very different to use. This means that adoption can be a challenge. Liquid petroleum gas, or LPG, is composed of a blend of propane and butane. It can be compressed into cylinders and cost-effectively transported, making it the cooking gas of choice for people living in areas that do not have pipe networks into their homes. The advantages of LPG are that it can be very cheap, especially in companies that are fossil fuel producers or have gas subsidies, that it produces almost no harmful pollutants for health or for the environment upon burning, and that it is composed of gases that are byproducts of other fossil fuels. This means that although LPG is non-renewable, it is close to being carbon neutral. However, there can be safety issues if strong regulatory environments are not in place, with risks of gas explosions. The fuel has to be purchased in whole cylinders at a time, which can make it incompatible with the cash flows of those with uncertain incomes. It is also unclear what will happen 30 years down the line when reserves of LPG run low, although research into producing the gas from biological sources is underway. Biogas is the mixture of gases, mostly methane and carbon dioxide, that are produced by the anaerobic decomposition of organic matter such as agricultural waste, food waste, and sewage. This process occurs in biogas digesters, which can vary from small household-level units, such as the one in this image, to large industrial plants, like the one shown here. High-quality biogas tends to come from these large-scale producers, as it is manufactured in controlled conditions with several processing steps in order to yield a high-quality end product containing minimal contaminants. Biomass can be burned for cooking, space heating, and electricity production. Biogas is truly sustainable, as its material inputs are renewable materials that can be replanted or regrown. It employs a circular economy approach that uses products beyond the end of their normal lifespan, and the equipment required to produce biogas is relatively cheap. The disadvantages of biogas are that production processes are inefficient, particularly for small domestic systems. Biogas contains impurities even after refinement, which can be corrosive and smell unpleasant, so some users dislike cooking with it as a result. Finally, it is unsuitable for urban areas where there is not a plentiful supply of raw materials. Lastly, it is important to appreciate that in reality people often rely on several different cooking fuels. For example, they may mainly cook with LPG, but prefer to use charcoal to cook specific traditional foods, and sometimes use kettles for boiling water. This practice is known as fuel stacking and is also observed with other types of energy, such as the parallel use of electricity to charge mobile phones and candles for lighting.